Okay, good afternoon, class. So at this point we are busy with geometry. We're wrapping up this topic. I think we got one more set of examples to do. But first we needed to complete 9.7. Your homework was 9.7, the even numbers. Okay. So I'm taking it upon myself to do all the odd numbers to give you a clear understanding of what is expected from you and the layout as well. If at the end of this you have any problems, please let me know. Thank you. It's a grade 8 learner. I just realized now. It's a grade 8 set, don't look after this stuff. Okay, so we are told that we didn't do number 5, no? Right, so we are told that GC is a tangent to the circle at C. So if GC is a tangent to the circle at C, what can be concluded from this? That C1 is equal to angle A2. Why? Tan cot. Then we are told that CD is drawn to intersect AG at F. AD, BD, FB are drawn. Then we are told that BF is parallel to CG. BF is parallel to CG. Then what can be concluded from here? F2 is equal to C1. Why am I particularly interested in that? Is because that is already marked. Can you see that? Yes, what do you want to say?
So, can C1 also be equal to FAB?
FAD. Sorry?
FAB.
FAB. No. You see, she asked, can this angle also be equal to the whole angle there? No, that's what you asked. Only if that is a tangent to a circle that's going through AFC. Then yes. But it won't be also because A1 has to be some size. You understand? Otherwise, according to that, A2 is then equal to that angle marked there that you indicate. You understand? But importantly, for the tan cot theorem, GC has to be the tangent for the circle going through AFC. Okay, which is not the case here. Then we are told that C1 is equal to C2. Much more dots going to come into play. Okay. If F2 is equal to x, give the reason 3 other angles equal to x. So if F2 is x, what can we say what is x? C1. Alternate angles. Then A2. Then C2. These 3 angles. You guys see that? Is that all that's it? Yeah? You went to Mr. Baba already? Oh, is it? Okay. I thought maybe she's gone already. Okay. So, here in A now we don't have to say. We don't have to say now that let F2 equal x. Why? Because they told us where the x fits. You guys understand? So if F2 is equal to x, we see that angle C1 is equal to x. Why? Why C1x? Alternate angles. With FB being parallel to CG. Right. What can we say from there now? Which other angle is equal to x? We see A2. So A2 is equal to xy. The tan cot. And then C1 is equal to C2. So C2 is also equal to x. C1 is equal to C2, that was given. Okay, there we got 3 angles equal to x. Okay, 6 marks or something like this. Alright, sometimes 3, sometimes 6. Depends. Huh? I'm taking this off so I can keep the diagram in focus. Okay. Yes? Why B3? Angles in the same segment. In what segment? Tan chord. Again, only if there's a circle going around through there. Then that angle is equal to that. But is that the case? No, there's no circle. And GC is not a tangent to the circle going through BDC. So therefore you cannot conclude tan chord here.
It will only be basically one triangle.
Not necessarily, no.
No
If you've got a circle, there's a tangent here. That angle is equal to that angle. Also, if there was a triangle here, that angle is equal to that angle. Yes. All 3 points of the triangle is touching the circumference of the circle. Must touch the circumference of the circle. Right. Prove that if B is equal to CB, if B is equal to CB, if B is equal to CB, then what is the case? Then what would be deduced from there? That C2 is equal to F2. Not so. So the contrary is true. The converse is true. If we then can prove that F2 is equal to C2, then FB is equal to BC. Not so? And looking at the diagram, you already know that F2 is equal to C2, which is equal to X. We know that already from the diagram. So therefore, FB is equal to CB. Why? Because they had sides, opposite, equal angles. So now I put a marking through there and there. Why do I do that? So at one glance I can see what is known and what have been calculated. Also, if we didn't manage to do that, also fill it in on the diagram there at that point so that you can use it in the next calculation if needed. Okay. Let's go with number B2. AFDB is a cyclic quad. AFDB. Cyclic quad. 3 ways to prove a cyclic quad. What are the 3 ways? Exterior angles equal to interior opposite. Opposite angles are supplementary, adds up to 180. And thirdly, the bow tie. Not so? Equal angles subtended by the same chord. And that's the one I'm going to use here. Because if you look at that there, this angle will be equal to that angle. Can you see that? Not the O means the X. But you see it. And there's it. There we go. Bow tie. Butterfly, whatever you guys see. No? You guys see? Whatever you see. Yes, called BT. Okay. So we say since. We state the obvious. Since what? A2 is equal to angle F2, which is equal to X. Therefore, AFDB is a cyclic chord. Why? Because they're equal chords. Subtend by same chord. Equal angles subtended by the same chord. Subtended by the same chord. Okay. Any confusion here? 2 marks on something like that? Lastly, D2 is equal to angle G. D2 is equal to angle G. Let's look where's D2. D2 with the table away. Just remember now, this is the cyclic one here. No? The cyclic one. Just put dots here. This diagram is cramped. Okay? And by doing that, I know that all cyclic quadrilateral properties are evident in this quad. Okay. If you want, you can even draw a circle around it. And again, oh my word. But draw a circle around it. Again, what you're going to notice is the diagram is going to become cramped or overpopulated. Okay, or busy. You see that? So, whichever way suits you, I'm okay with it. Okay, as long as you get it right. So let's look at D2. Here's D2. Not the X, we are already using X. Let's use a circle. Right. So D2 is equal to which angle? D2 is equal to which angle? F1. Why? It's easy, it's the same. What is it? Angles in the same segment. Yes. What are you talking about?
What segment?
This is a circle going through here.
Oh, got it.
Remember, if it's cyclic, if the quad is cyclic, then that's mean to say a circle is going through there, or can be drawn through there. You understand? So it's cyclic. So since it's cyclic, what do we know? D2 is equal to F1. Why? Angles in the same segment. Lots of. Then F2 is equal. F1 is equal to what? Yes, F1 is equal to GY. Corresponding angles. Therefore, D2 is equal to G. You see that, people? So I'm going to keep my X out of it for today. Or this one. Let's just do it without the X. No? We're big now, we're moving on with our lives. Alright? Not so? No? Guys, ready to move on with your lives? Yes. Right. So let's go. Angle D2 is equal to? Angle D2 is equal to? F1. Why? Angles in the same segment. And it's coming from arc AB. You don't have to say that part, okay? Then F1 is equal to G. Why? Corresponding angles with BF or FB parallel to GC. So what do you notice? If D2 is equal to F1 and F1 is equal to G, therefore, in conclusion, D2 has to be equal to angle G. Okay? You guys understand? Right. Go to number 7. In number 7, we are told two circles touches at O. Right, two circle touches at O. FOG is a common tangent. If a common tangent, what does that mean? Sorry? Common tangent means to say it's a tangent in both circles. So if that is the case, then O1 is equal to angle B. O1 is also equal to which angle? O1 is equal to angle O5. O5 is equal to which angle? Why? Tan point. O5 is equal to the same as O1, vertically opposite. So you see that this angle is equal to that angle, so what can be concluded? AB is parallel to ED. Why? Alternate angles are equal. You see that? Without looking at the questions, and yes, they want you to prove that already. Can you see? Then it says that BOD are double chords. What does that mean? BO is a coordinate, BD is a chord split by point O. So BO and OD are chords in their respective circles. Also, by them saying that it's a double chord, that means to say that it's basically a straight line. Okay? Both of them, E and AE and BD. C is the center of the larger circle. People, if this is a center, what do we know? Angle at center is twice angle at circumference. Not so? Can we tell those lines are drawn? Right, you're going to bring the X in? Have you grown up past that now? You're using the X?
No.
Not yet, okay. Still dependent on that X feelings, no?
Yes.
Alright, so let's bring, where are you going to put the X? Where you want the X? O1. Boring. Okay, let's go with O1. Then O1 equal X. So if O1 is equal to X, where do we go from here? They want O1 is equal to D, no? O1 is equal to which angle?
D.
Huh?
D.
Why? Listen, we need to end of there. O5. So we say O5 is equal to X. Why? Vertically opposite. Then angle D is equal to X. Why? Tan chord here. Therefore, angle O1 equals D is equal to X. Alright? You guys got it?
Yes.
Again, I'm taking this off because of space, okay? Let's go with B. We spoke about that one already, not so?
Yes.
So we need to know that B is X. Why is angle B X? Tan chord here. So what do we say? State the obvious. Since angle B is equal to angle D, which is equal to X, therefore AB is parallel to ED. Why? The alternate angles are equal. There I can officially put the lines of parallel in there. Okay? Next question. C. You must prove that C1 is double angle B. But what is B? X. Did you see B? D is X. B is X, sorry. So if we can prove that C1 is twice X, we've done the job. Not so? So we know that 2B is 2X. Angle C1 is equal to? Angle at center is twice angle circumference. Angle C1 is equal to? 2X. Why? Angle at center is equal to 2 times angle at circumference. So C1 is 2X. Therefore, C1 is equal to twice angle B, which is equal to? Okay? Easy, no? It's the last one of this exercise, which is number 11 as well. Last one. So here we are told that BC is a tangent to the circle at O. BC is a tangent to the circle at O. If that's the case, what do we know? What do we know, people? B3 is equal to angle A1, absolutely. Okay? Then we are told that chord AB, this line here, chord AB is equal to BC. What can be concluded from there? B1? No. A1 is equal to C. Yes. Why? Angles opposite equal sides. Then we are told that AC is drawn, cut in a circle at D. OA, OB and BD are drawn. Let angle C equal X. Right. Angle C is equal to X. Prove that. Must prove that BD is equal to DC. If those lines were equal, then B3 would have been equal to angle C. Not so. But to prove that the lines are equal, we now prove that B3 is equal to angle C. And there is already evident that it will be. Can you see that, people? Is this work difficult? Huh? No. Easy. Right, so we're going to start testing you on this. No? We're going to start giving you tests from next week on. Alright. People? Sorry? You are going to move classes? Yes. The maths lit learners. No, the maths lit learners going to be split into two. Like the maths is now?
So is the math
Going to merge, yes. By one teacher. No, as soon as we're done with this section. I just need the recordings of this to be done. Then we're going to do this. Okay? Huh?
Wait, what class we need first?
Yeah. Yes, there's only 12 there. And 17 with you guys.
17.
How many are you?
12, 6, 9, 11, 10.
You guys can fit as a group anyway.
Oh, 11.
But it's fine, listen.
So what?
Sorry?
That's not going to teach you
Listen, I'm trying so hard with you guys, no? But on the outside looks like I'm not doing my work. So you guys are not getting the results I expect you to get. So if I teach some maths lit, then everybody's going to think I'm doing my job. No? Because I listen. Because listen. Everybody gets good marks in maths lit. So it looks like the teacher's doing their job.
Exactly.
Sorry?
Some people could be wrong and get good marks.
You did probably longer last year term too. But okay, here we go. Listen, let's go, listen. Here's your X, okay. Now then, what can we say about that? Okay, sorry, this is a very important word. Hello? Speaking? So, sorry about that. So, with angle C, so do we need to say let C be X? No. They brought their own X to the party, no?
Yes.
Right, so we play around with the X. Go for it. B3 is equal to X. Why? What's wrong with you? It's A1. Now you see now why I must go teach a little maths then. Just for my own sanity. A1 is equal to X. Why? Angles opposite equal sides. B3 is then equal to X. Why? Tan code. Yeah, keep on believing that. You will come a time that we believe the lies we tell ourselves. Okay, so what can we say now? Since A No, man.
B3.
Guys, B3 is equal to C, which is equal to X. Therefore, DB is equal to DC. Why? Sides opposite equal angles. That there, whoops. DC and DB. Okay. Right, let's carry on. Now it says write O1 in terms of X, showing all working on. So O1 in terms of X. So here O1, angle at center, is twice angle at circumference. Lots of. So which angle do I need? D1. Okay. But D1 is equal to what? Is that not the exterior angle of a triangle? Exterior angle is equal to sum of two interior opposite angles. My words. Right, D1 is equal to 2x. Exterior angle of triangle. Dot dot dot. Is the exterior angle of triangle DCB. Triangle DCB. So that is 2x. So O1. What is O1 equal to? O1 is equal to 2 times 2x, which is 4x. Why? Angle at center equals 2 times angle at circumference. Okay, and there we go. Now that brings us to the next example. Was there any problems with the even numbers? Yeah. Okay, what was the issue? Alright, your homework is going to be 9.8, the odd numbers. Okay, 9.8, the odd numbers. In tomorrow's lesson, not tomorrow, on Tuesday. I'll just run through them all. Okay. So what's going to happen is I'm going to send the memo, the full memo to this chapter to your phones. Okay. So you'll have a written out memo of this as well. So now for this, you'll have a written out memo. You will have a video memo, explanation, and you have your own memo. Let's see what you do with it. Okay. Right, what page was this on? Page 319. Right. So don't forget 9.8 is homework, ne?
Yes, sir.
Right. Any problems number 2? Number 4? No. Number 6? 6 is the issue, okay? Oh, that's a nice one. They want this in terms of X. My favorite. Right, we are told that AB is the diameter of the circle. People, if AB is the diameter, what can be concluded from there? AB is the diameter of the circle. Nothing. Right. Then we are told that it cuts EC at a right angle. If that is the case, what do we know? This is 90 here. So what can be deduced from there? Sorry? That CM is equal to MEY. Perpendicular from center to chord. Yes, we done that in our first lesson last term, dealing with geometry, that theorem. Theorem 1, yes. Now you see now. That's all I need to tell you, you see. Then, OC, right, all of those lines are drawn. Right, A. Why is CM equal to ME? The perpendicular from center to chord by sixth chord. Not so? Right. Let's go with B. Prove that B1 is equal to B2. How are we going to prove B1 is equal to B2? Proving congruency. So you say in triangle CMB and triangle EMB. That is the right order that we needed in as well. We can say that BM is a common side. As you can see, BM is in both triangles. Okay? What else can we say? CM is equal to MEY. Proven. Proven above, or proven in A, or just proven. M2 is equal to M3, which is equal to 90Y. Straight line. Angles on a straight line. Or we can just say that the lines are perpendicular. Not so? Enough to prove congruency? Yes. So therefore, triangle CMB is congruent to triangle CMB EMB. Why? Sorry? Side angle side. Why not RHS? You're not using that partner? Yes. So what do we conclude then? So this is enough to conclude. Therefore, B1, that angle here is equal to that angle. B1 is equal to B2. Why? Because triangle CMB is congruent to triangle EMB. You don't have to say this in this setting. Okay, but you'll see me say it all the time. Okay? So that's that. Then, again I'm going to take this off so that you can keep the diagram in focus. Okay, so we got that. So B1 is equal to B2. Right, let's go to C. If B1 equals B2, which is equal to X, okay, express angle D in terms of X. What will angle D be? 2X. Why is angle D 2X? What? Angles in the same setting. Not so. So big D, capital D, whatever, is 2X. Angles in same segment, and it's coming from arc CE. Okay. D. Look at D. Prove that OFCD. OFDC. Prove that OFDC is a cyclic quad. How do you prove cyclic quad? One of three ways. Exterior angle equals the interior offset. That's the one I'm going to use. Not so. Why? Because this is your exterior. The interior opposite angle is already marked as 2x. So if I can prove that O1 is 2x, I've done the job. How else do we prove cyclic quads? Equal angles subtended by the same chord and opposite angle supplementary. I could have used that as well. Okay. But people, O1 is equal to 2x. Why? Why is O1 equal to 2x? You guys convincing me that I'm doing the move. Angle at center is twice angle at circumference. Not O, it's O1. Okay. So angle O1 is equal to 2x. Angle at center is equal to 2 times angle at circumference. So, is that not enough? We can state the obvious now. So we say since O1 is equal to angle D, which is equal to 2x. Therefore, we answer the question OFDC is a cyclic quad. Why? Because the exterior angle equals the interior opposite angle. Very important here, don't make the mistake. If they ask you to prove it's a cyclic quad, use cyclic quad in your reason. Don't make that mistake. Okay? This reason here always carries one full mark. Okay, so your reason is not in the right place, or you will slip up there with cyclic quad, you lose it. Okay? Alright. People, that was number 6. Any problems with number 8? Yes? The bell is going to ring now, so I'm going to cut this along for the next lesson. Any problems with number 10? No. Was there no 10? So 10 is fine. So this is where we'll start in our next lesson, and then the examples as well as the odd numbers. So we're going to do one sweep in terms of the next exercise. Okay. So I'll start off with number 8, then I'll do the examples, and then the odd numbers. Okay. Which then will conclude this exercise with this chapter. People, a very, very important chapter to understand most of it. Okay, the reason for that is because the last part of the grade 12, the last part of the grade 12 geometry, okay, for similarity we would need to know how to prove or use the circle geometry theorems as well. Okay, so it's going to be beneficial for grade 12 as well. A big chunk of it is needed for the grade 12 section. Okay. You guys may pack up? Yes? Sorry? Cycle test, probably 35 marks will be on circle geometries out of 50. Okay. So if I'm you, I would know this works solid. Okay, if you answer the section only, you can do well. But you guys must want to do well. Enjoy the rest of your day, people, and the long weekend. Good afternoon, class. Yes. Yeah.